Welcome to Inside ITOM Solutions, a dedicated video series where we explain how to monitor and manage various IT systems with ManageEngine's IT solutions. I'm Vishnu, and in this video, I'm going to talk about OpManager's AI-powered alarms. We have seen how OpManager can monitor the KPIs of your server arrays, and we've also seen how you can track key processes and services. But as you scale your infrastructure, managing individual alerts for thousands of devices becomes a challenge. How do you ensure your team is only alerted for genuine issues? OpManager's AI-driven adaptive thresholds help you scale your monitoring across large and complex IT systems without compromising on the quality of your alarms. To understand how this works, we first need to look at the basics. In OpManager, a monitor is used to track a specific metric such as CPU utilization, memory usage, or disk space. A threshold is a condition you set for that metric. When the actual monitored value violates that condition, OpManager raises an alarm. Usually, you would configure manual thresholds, which are static limits. Let's see how they work in the product UI. Go to Settings. Under Monitoring Settings, choose Performance Monitors. Let me choose the CPU utilization monitor. You can configure the threshold values and their conditions here. You can choose things like the monitoring interval. The interval determines how often OpManager monitors this specific metric. You can also change the unit of measurement for certain metrics. You can set up different kind of threshold conditions in OpManager depending on what you're monitoring. For instance, you can set up a greater than or equal to condition. This means that if the monitored metric reaches or crosses the value you have set here, you get an alert. You can manually add 3 alarm thresholds for each monitored performance metric, with each corresponding to a particular severity level. When the monitored value of the metric breaks the threshold condition that you have designed for that specific metric, you get a corresponding alert. First one is attention. This is the lowest urgency level used to flag early deviations. Number 2 is trouble. This indicates intermediary urgency, signaling that a metric is moving towards a critical state. Number 3 is critical. This represents the highest urgency requiring immediate intervention. Alarms generated for each severity are color-coded and flagged, helping your team instantly triage and prioritize their response. However, static limits don't account for natural performance shifts like a server's CPU spiking during morning login hours or a database running heavy backups at midnight. This often leads to alarm noise where your team receives false positive alerts for expected behavior. Adaptive thresholds solves this by using machine learning to fully automate the process. Instead of a fixed number, OpManager calculates a baseline, which is the predicted normal performance for that specific device at that specific hub. You have to enable adaptive thresholds globally. As we explained in the previous parts, you can find the global settings for your monitors in the Settings tab. To enable this feature across your environment, navigate to Settings, choose Monitoring, and select Adaptive Thresholds. Here, you can flip the toggle to enable adaptive thresholds globally. Once enabled, any changes you apply here will reflect across all devices and performance monitors. Now, let's go back to the performance monitors. Under Settings, let's choose CPU utilization. As you can see, you can now enable adaptive thresholds here. When you enable adaptive thresholds, you can configure the deviation values. Since OpManager automates the calculation of a single baseline value, you can use these deviations to define the urgency of the alarm. These can be set as an absolute unit or as a percentage of the predicted baseline. For example, if OpManager calculates the normal baseline for a server to be around 65% for this hour, and you set your attention, trouble, and critical deviations at 5, 8, and 10, the thresholds will automatically set to 70, 73, and 75% respectively. In this section, you will also see suppress limits and static limits. A suppress limit allows you to set a value below which alerts are automatically ignored. This is useful for preventing unnecessary alarms during minor fluctuations. On the other hand, static limits act as a hard cap. If you set a static limit at 95%, OpManager will always trigger a critical alert if that value is reached, regardless of what the AI calculated baseline is. To ensure the highest level of predictive accuracy, it is recommended to let OpManager monitor a device for 14 days before enabling adaptive thresholds. This is basically the training period. It allows the machine learning model to analyze your real-world data and understand recurring patterns such as seasonal traffic bursts or scheduled maintenance windows. Now, if you want to apply adaptive thresholds to a specific type or model of a device, you can do that through device templates. Go to settings and choose device templates under configuration settings. When you select a specific model, you can see the list of monitors supported for that device. You can configure adaptive thresholds for that model alone. This is particularly efficient for IT automation when deploying a new infrastructure. OpManager establishes the baseline automatically as it gathers data. You can also set adaptive thresholds at the individual device level. Go to Inventory and select the specific device you want to edit. Navigate to Monitors, click on the Edit icon and choose the Adaptive Thresholds option. This dynamic approach is vital for anomaly detection. Adaptive thresholds also helps with alarm noise suppression. This is how OpManager gives you intelligent, in-depth visibility that adapts to the evolving workloads of your network. We'll be releasing more videos explaining key concepts and features of our IT solutions in the upcoming weeks. Subscribe to our channel and click on the bell button to ensure that you never miss an update. Thanks for watching. See you in the next video.